So hello everybody, this is your Aman sir, and in this series we just started for our very first chapter of class 12th mathematics, and this chapter actually name is relation and function. So for this chapter I'm just saying this chapter is the whole essence of your 12th, and apart from that I'm just saying this chapter actually use in your upcoming chapters, or I can say the functions and the relation are also the fundamental chapter you have to do for your concept building thing. Okay, so students, this chapter is very interesting and also some tricky part over here. So lecture 1 of the series, that is the types of relation, and first. Okay, so without any delay, let's start today's lecture. Okay, so students, actually what is in the relation? Okay, so in 11th class also there are one chapter also that is in the relation and function is in here, that is also somewhat about the what is the relation. So actually what is relation, just revise from our what in with the 11th class also. Okay, so let's take what is exactly a relation. Okay, if I can say just try to give firstly the example, then I am trying to give whole thing about the relation as well. Okay, if I can say there are one universal set, I can say the one universal set, and that is what 1 2 3 4 5. Okay, no problem, sir. Okay, and I can say I'm not taking this as a universal set. Okay, I can say this is my A set here. Okay, not U, I'm just taking as a set here, no problem, sir. Okay, if I take the A set here and the element are given in that this A set, actually you can say, sir, this element giving 1 2 3 4 5. Okay, so exactly what the relation you have to say, the relation actually is what somewhat about, I can say the relation is forming with A cross A. So what is exactly A cross A? So I can say, sir, A cross A is a pair of element. I can say the pair of elements which actually belongs to my A set here. So which actually belongs to my A set here. Okay, so no problem, sir. Okay, sir. Okay, if I can say so what is the A cross A? So actually A cross A pair of the sets, okay, sir. Okay, so can I say this relation, this relation is somewhat, I can say this relation is also a set for what? The pair of the elements. I can say, sir, this if I take one here and one here for the first element, and the second element here is 2. Okay, that's no problem, sir. Let's the common, the pair elements, the relation is what? The pair elements from our original sets. Okay, can I say 1 3, sir? That is very true, sir. Can I say 1 4, sir? That is also true, sir. Can I say 1 5, sir? That is also true. These all about what? These all about of your 11 things relation. Okay, if I just cross whole over set with the set, then we just obtained the one set also, and we for that set we can call it as a relation set. So what is the relation set? Okay, so all the element here, can I say 1 1 here? You can say yes, sir, because as a first element we can take 1, and as a second element you can take 1. Okay, can I say 2 1 here? You can say yes, sir, because is this 1 2 or 2 1? Is it different or not? You can say yes, sir. It's just like different as a coordinates. You can also say this relations or this pairs exactly a coordinate here. So in the coordinate geometry you have already learnt in your 11th or I can say the 10th part also, the coordinate system 1 2 and the 2 1 are so different, na? So that's how like this relation works. So I can say the 2 1 are also different from 1 2. I can say the 2 2 here, I can say the 2 3 here, I can say the 2 4 here, and I can say the 2 5. So these type of the relation which formed with what? A cross A relation. Okay, that's no problem. So these all about the revision of the relation that I already learned in our somewhat in our 11th class. Okay, okay. So if I want to find these types of sets, so I can say if I take okay, if I take A and I can say A cross A. So the total sets or the total number of pairs these forms can be 5 into 5, that is 25. Okay, so the total number of pair that will be formed in this relation actually is what? Actually is your 25 pairs. Okay, these are the total numbers here. Okay, let's say what is the relation here. So you can say, sir, I'm just not taking whole sets here, or I am just not taking whole pair in this set, in this relation. Actually I am just taking some pair. For that pair only I am just giving you a condition. So what is the condition I can give you? Then according to that condition you just give me those values only. That is what our relation. Okay sir, it means if I take A cross A the whole set, or I can say the A cross A for my condition is my universal set, then apply those conditions and find that relation. And the relation word actually means that. Okay, so you can relate to those pair of the element, then after that relation you just come with your solution here. Okay sir, that is no problem sir. Okay, let's see take the some definition thing also. Okay, so I can say a relation, okay, is a set A, no problem. In a set A, I can take the set A is a subset of A cross A. I can give you a idea na. You can just find the relation here for what? The subset of A cross A. So all the whole elements or all the whole pairs which exist in A cross A, that is not in our I can say the relation here. The relation here is what? The relation is exactly here is somewhat the subset, or you can say the sum pairs which I with my condition here. Okay, so this is the relation. So sir, why are you give this relation thing here? I can say I'm just taking that this relation is A cross A, that's all. If I take the more thing here and I take more condition here, then the relation must be some other relation. Okay, no problem. Okay, does the empty set, let's see, these are the thing. Does the empty set and A cross A are the two extreme relation? That is the thing. So this is what, if I take all the elements now, if I take all the pairs, that is the 25 pairs here, that is what, 2, 5, I can say 3, 1, 3, 2, 3, 3 also. So these are all 25 pairs. So if I can say the relation of these whole pairs, that is our extreme relation. In beyond this there are no other relation also. Okay, so these are what? These are our extreme relation. Is phi set is also a relation? You can say yes sir. If there anyone, not a single pair that comes with our condition, then I can say my relation is what? My relation is exactly my empty set. Okay sir, that's how the things work. Okay, no problem. Let's see with the example, and you can definitely understand these things. Okay, let's say for illustration, sorry, the consider a relation R in the set what? Okay, can I say this is my A set and we just take the relation R from this set only. Okay, given by, okay, so what is exactly given here? What is exactly? The R actually represent what? The R actually represent my relation. Okay, the R actually represent here what? It is it my relation? Okay, no problem sir. Okay, so these pair actually these pairs are actually pairs which come under in my relation set. Okay, this pair actually comes in my relation set. Okay, like my set builder form that I already learned in my 11th class. If you remember this, like my set builder form, on that thing we just take one element there, and for that one element we just take x. The variable here is x, but in that relation you just take pair wise na, so I can just give the pair that is A comma B, and for this pair this condition must be given. Okay sir, so that this is somewhat I can just write here. Okay, no problem, I can just write here, just ignore the next question, but I'm just write here, that is my the set given is to you, that is 3 1 2 3 4, no problem sir. And my whole relation is actually what? My whole relation is actually r equals to 3, and there are a comma b, that is colon, and a minus b equals to 10. Okay, so this is what? This is my condition for my relation here. No problem sir. So this is only the condition here. Okay, let's find the relation part here. Then let's find the relation, or you can say the elements which are comes in, or you can say not the elements, no, the pairs which are coming in my relation part. Okay, so we can take a comma b, and this a comma b exactly referred to what? This a comma b is exactly referred to my original set, that is here is my a set here. Okay, no problem. Is this any pair? Can I take 2 times the pair? 2 times, you can say yes sir. You can just take all the 2 elements here and just make the a cross a set here. Okay, no problem. Okay, if I take all a cross a, okay, let's see, let's take a cross a here, and I'm just taking all the a cross a pairs. Okay, this is my only the first time and last time I'm just taking all the a cross a. Okay, you have a common sense, you have a thing, you can just think about it, and ultimately you come with the solution without any solving a cross a, because for the large element sets na, the a cross a things are very difficult to write here only. Okay, so for the sake I'm just writing the a cross a. So you can say sir, the whole element which exists in a cross a is what? You can say 1 1, okay, 1 2, you can say 1 3 sir. Okay sir, 1 4 here, then you can say sir 2 1, 2 2, no problem, 2 3, that is also no problem, 2 4, then you can say 3 1 and 3 2, okay, 3 3 and 3 4. After that just take the 4 element there, the 4 1, 4 2 and the 4 3, and what? The 4 4 here. Okay, the 4 4 here. Okay, no problem. Okay, so these are all my a cross a set which are coming with the a set only. Okay, let's see if I take this condition, I'm just taking all those elements by taking a minus b. By taking these elements actually comes with the difference of what? 10 only. Okay, can this is possible here? I can say sir, if the 1 is a here and the 1 is b here, because this is just like represent a comma b na, so I can say sir 1 minus 1 actually is 0, so this condition is not true. 1 minus 2 here is what? 1 minus 2 here is minus 1 here, so sir this is condition is not. Is there any element there that is actually gives the difference of 10? You can say no sir, there have not a single element here that is comes with the difference of 10 here. Okay sir, it means in my relation there have no element exist here, or you can say there no pair exist here for what? This condition only. So this is what? This is my null set, or I can say the relation actually comes with what? My phi set. It just simple means there have no pair which is found with the condition here. Actually sir, okay student, so this is the with the help of this example I can say this is the empty set. And what is empty set as actually means to say, that is as no pair of a comma b satisfy the condition of a minus b equal to 10. Okay sir, I got the point here. Okay, so student, this is all about the thing. You have to give the set here. Okay, let's see for this example, and I can say the R set here. I can say the R dash set here. Okay, for A set you can just take this A set in this example also. Okay, I can say this example a comma b, that is just represent what? Represent my a minus b mod actually equal to greater than 0. So if the condition is true here, then I just take all the set in my relation, and that's actually a relation set. I can say this is my answer for this relation set. Okay, let's say a minus b. So I can just give the thing here. So if I take the whole pairs from this only, I can say 1 minus 1 is 0. You can say 1 minus 1 0. You can say, sir, yes, this condition is true because in this condition this says that a minus b mod should be greater than equal to 0. So is it equal to 0? You can say yes. So I can just take 1. Okay, if I say 1 minus 2 here, then if 1 is a and 2 is b actually, then I can say 1 minus 2 is what? That is minus 1. And if I take minus 1 mod here, if I take minus 1 mod here, that is ultimately comes with what? Ultimately comes with 1. And is it 1 is greater than equal to 0? You can say yes, sir. So is this condition is also true? That is true, sir. If the negative things are, if the negative numbers are also be there, then it's ultimately gives the mod here, and ultimately by the helping of the mod, the number should be positive here, and the number should be positive. You can say this must be greater than equal to 0. So is this the all set here? Is the all set here are actually describe my condition, or actually comes with my condition with a satisfying thing? You can say yes, sir. All the conditions, or can they say all the pairs which exist in our a cross a is exactly in a satisfied with what? My mod a minus b greater than 0 condition. Okay, sir. So that's how the things is going. So I can say is the whole set a cross a, the whole set as all the pairs that is satisfy this condition only. So these are all my two extreme example. One example says that is maybe the relations comes with my phi set here, or maybe the relations comes with my whole set. Okay, whole set for what? The whole set of a cross a here. Okay, the whole set of a. So this is all about my two extreme examples. Okay, sir. That is very understandable. Okay, let's one thing I can say. If I take a comma b na, then we just say that, and I can say this a comma b. If I can say like if I can say 1 comma 2 is actually belongs to my relation. So you can say, sir, this 1 comma 2 actually belongs to my this relation, na? Okay, sir. So I can just say just whole thing that is belongs to my relation set. That is not a problem. Okay, how can I just read this thing? So we can just say that A is related to B. So actually these pairs are related to each other. Okay, related in somewhat. You can say if the pairs are there na, so there is something that is or you can say in the human psychology, or I can say with the twisted manner, if there have the husband wife here, then there have some relation. Okay, so with the help of this, I can just say if there are a pair, then it is must be A is related. A is related to what? A is related to B. So I can in this example only I can say the 1 is related to my 2 here. So this is what the thing you can told with the language, and you can just write this thing also. If A comma B are in your relation, then you can easily say A are B. Then automatically this means that A is my related to B only. Okay, sir. Okay. If the A and B are not there in the relation, so you can say A is not a related to B, or I can say A are cross with B. Okay, that's how this the simple definition of the simple things will be related with the relation part. Okay, sir. Okay. Let's take the example here. Very simple example, and I can just say I'm not requiring here always give you the A cross A whole set. Okay, let's just define with your mind only, and just take as with the mind, or as with the smartest you can. Okay. Let's say if I can take a set here, and let's say let R be the relation in A. No problem, sir. Given that R, what is my relation? That is A comma B. That is expression actually related to what? A minus B equal to 2. No problem, sir. So I can just give the relation here only. What relation? I can just give the relation here only. That is only the A minus B equal to 2 here. Okay. So if I can say, let's say if I can take 1 comma 1, you can say no, sir, because 1 comma 1 difference is 0. If you can say 1 comma 2, you can say no sir, because 1 comma 1 and 2 differences exactly. If I can say 1 comma 2, then the order should be must in the series. Okay, so A here, B here, so you can say sir 1 minus 2 actually minus 1 here. Okay, so that is not the difference here. If I can take 1 comma 3 here, so what I have to do, I can say this is A, this is B, and for this the difference here, that is 1 minus 3, that is ultimately minus 2, and I want 2 here now. I am not wanting the minus 2 here. So you can say sir this pair also not be satisfied. Okay, so for 1 there have not other pair that should not be satisfied here. Okay. Okay, if I can take the 2 here, so you can say sir, if I can take 2 comma 1, then this difference is 1. 2 comma 2, then this difference is 0. If I can take 2 comma 3, then the difference comes in what? Negative form. Then the I can say the 2 elements are not being used for a first element. Okay, okay. If I can say the 3, if I can say the 3 one, okay, let's see the process or the mind training are only be like this. Okay, you just take one element, then the other element, then take all the pairs with that element, and just try to find the satisfying that condition which I given you in your relationship. Oh, not a relationship, in your relation here. Okay, okay. So if I take 3 comma 1, I can say the 3 comma 1. Is this difference is 2? You can say yes sir. So in my relation, I can say 3 comma 1 is in my relation here only. Okay sir, no problem. Okay, okay. If I can say so the 3 part is over. If I can say 4 comma 2, if I can say the 4 comma 2, then the 4 comma 2 are also difference with 2 here only, and with the common difference, if I can say the 4 comma 3 here, the 4 comma 3 here, then you can say that these the difference of this set also are 2 here, and I can say the 6 and 4. So this is also the 2, the difference of this both the numbers are 2 here. So that is ultimately comes with my relation thing. Okay sir, okay sir, that is somewhat the good thing. So this clearly we can say this, the relation set here is this. Okay, okay, clearly I can just say 3 is related to 1 according to my condition, 4 is related to according to my condition, 5 is related to 3 according to my, 6 is related to 4 according to my. Acha, is 1 is actually related to my 2? With the condition, if I can say the 1 is related my 2 here, you can say no sir, because the difference must become here is actually minus 1. If I can say okay, if I can say I can say 1 or 3 is my relation here, you can say no sir, because the difference actually 1 minus 3 is what? Here is minus 2 here. So this is not our relation here. So this is some the relation you can given that is not actually related to the and the etc things. That means you have to some other relation also that is somewhat not related to each other. So this not be just given to on your upcoming examples. This is the only way, or I can say in this example only I'm just showing you what is not relation here. Okay, okay sir, okay sir. Okay, okay, let's say the domain and range of the relation. So very easy. Okay, okay, so in simple words, I can say if there a comma b, if there a comma b, that is belongs to my relation here only. Okay, the a comma b that is belongs to my a relation here. This a actually comes, or you can say this a actually is my domain. This a actually is my domain, or I can say for the pair of the coordinates now, you can say the first coordinate is my domain part, and the second coordinate, that is my b, that is my range part. Okay, so this is all about only domain and range of our relation here. Okay, is the domain of and range in my function actually the different thing. Okay, So in the relation, you can just easily say, sir, what that is, if A comma B pair actually relate, or I can say that belongs to my relation, then the A actually is my domain, or you can say the first coordinate actually is my domain, and the second coordinate, that is B, actually is my range here. Okay, sir. Okay. Let's say the definition part here, and I can just say, let R be the relation in the set. No problem, sir. R be the relation on the set. Then set of all first coordinate. See na, set of all first coordinate in the elements of R actually the domain of R. Okay, so if I can say the relation part, and I can say the 1 comma 2 here, and I can say the 3 comma 1, I can say the 5 comma 5. So in this whole relation, I can just say 1, 2 and 5 actually is my domain. Sorry, not 1, 2. I'm just saying 1, 3, 5 actually what? Actually is my domain here, because the first element of all the pairs here are what? 1, 3, 5, and I can just say 2, 1, 5. Here is my range for this relation only. Okay, sir. Okay, so as a write as domain of R, no problem. The set of all second coordinates of R actually is called my range of R, and we can just say the range of R. Okay. So in the set builder form, and if you try to give what representation for domain, so you can say, sir, domain is what? Domain is a set which belongs to actually A, and this actually A from what? You can say this actually A comes with my relation that's give the pair. So the first element actually is my A. So domain elements are actually represented with A, and similarly I can say the range elements is there are represented with the B here only. Okay, sir. Okay. Let's come on the discussion with what example part. Okay, this is the twisted example here. I can just easily give you the idea for this example only. Okay, let A be the set here that comes to 1 to 16 numbers here. Okay, and let R be the relation in A. Okay, no problem. And given by this is my relation something. Okay, so this is what the relation I have given to you. Okay, so I can just take the thing here, that is what I'm just try to give you an idea. So this is what I'm just try to solve the relation. Okay, I'm just try to solve this is my condition here only. Okay, this is my condition here, no problem, sir. Okay, so what is my condition here? That is B equals to A square, and my actually relation is what? My A comma B. Then I just find the A comma B here, and I'm just find the A comma B here. So if I can take A1, so you can say the B equals to 1 square. If I can take the A1 na, so I can say the 1, so you can say it's a B is also 1. So for this example only, or if I take the A1 here, so the pairs comes should be 1, 1. No problem, sir. Okay, so then you, sir, and you give me an argument that, sir, then this is all about, you can just put the 2 here, you just put the 3 here, and the 16 numbers you are putting here, and just comes with the B here only. Okay, so wait students, actually what I'm do here, let's examine. Okay, let's say the A equals to 2 here, and I can say that B equals to 2 square, and B is actually ultimately is 4. So the relation is what? You can say A is 2 here, and ultimately the relation you can say the B is, but the 2, 4 pair comes in this relation only. Okay, if I can say A equals to 3 here, you can say, sir, B equals to 3 square and the B equal to 9. What actually do you, sir? You just try to give all the elements here. Wait students, wait. Okay, let's say A equals to 4 here, then B equals to 4 square, then you must be taken, that is B equals to 16, that is A comma, both not A comma, that is the 4 comma. Okay, so what? This is my 4 comma 16 here, sir. No problem, students. Okay, let's say if I take the A equals to 5, then there are any problem? You can say no, sir. Okay, let's see the 5 square here is what? You can say the B equals to 20. Okay, sir, so I can take 5 comma 20. No, students, that is actually wrong here, because actually this 20 should be belong also in my A set na. The A set range actually 1 to 16. So if I take A5, I am just taking the A5 here, there are no problem here, But for B, I'm also taking from what? I'm also just matching with my A set. So is there any element which are in A set here? You can say no, sir. So actually the upcoming elements are giving me the elements that is must be greater than 16 na. So upcoming elements are not be there. Okay, sir, it means the relation part actually comes with what? This relation only. Okay, sir. So here is the solution na. This is the relation that is comes with the this set of the pairs. Okay, no problem, sir. Okay, so what is the domain here? So you can say, sir, the first, all the pairs have the first element are the domain. So you can say the domain of this this domain, you can say dome. You for the domain you can write the dome, and in bracket you can say the R, that is represent this relation, and upcoming set here is the only set, the element set here, that is contain the 1 1 1 element, and you can say this actually the first element, or you can say the first element of the coordinate that is must be given in your R set, and the second element coordinate, that is 1 4 9 16 R also is my range here. Okay, sir, something I like this, sir, something I enjoying this, sir. Okay, students. Okay. So let's see the some condition, also some particular condition types of relation. Okay, so what is the empty relation? I'm just taking this class for the empty relation just before this slide. Okay, before this slide. Okay, what is the exactly empty? You can say, sir, a relation are in a set is called empty set if no element of A is related to the any element of A. Is there not a single element, or you can say the not a single pair according to my condition are in my relation. So in my relation actually it is the empty set, or you can empty relation, and you can say void relation also. Okay, the some other words to defining the empty relation is what? Void relation, or you can just say this is what? This is the phi set here. Okay, let's assume, and I am also just before you, I'm just taking one example also. Okay, this is my second example, that is if I take the A set here, that is 1 2 3 4 here, no problem, sir. Let R be the relation, and given by this is the relation. Okay, so if I try to find whole things, is there any element which are differences with the differences, or I can say now any pair here in your A cross A, that is comes in your mind. Okay, no need to just write all the A cross A pairs. So that is the foolish thing you have to done in this relation only. Okay, so what you have to do, you just take the pairs and just try to find is the pairs difference are 6. I am saying no, because the ultimate greatest difference here is what? 5 minus 1, only the 5 minus 1. Okay, if I take 5 minus 1 na, then ultimately it comes with the 4 answer only. That is the greatest difference that comes with this set only. Okay, and I want the difference of 6 here. So is there any relation that comes with this condition only? I'm just saying no. So actually R is belongs to my phi set here. R is not belonging a single element pair that is in your relation. Okay, sir. Okay. Let's say the universal set here. Universal relation I had already learned in my previous PPTs here. No problem, sir. Let's understand one time more. Okay, let's say the R be in a set A and is called a universal set. How? If each of A is related to every element O, is there all whole A cross A pairs are in my relation, then I can say this relation is actually the universal relation. Okay, this relation is actually what? This relation is actually my universal relation, and according to that the universal relation is actually is what? Your whole relation whole set that comes with A cross A. So if I take A cross A here and just take A cross A in my relation, then you can say this whole relation are my universal relation. So that is all thing for what? For my universal relation here only. Okay, let's say. Okay, so this is something, the point that I just want you just remind. Okay, just remind in your mind, and take a note here that both the empty relation and the universal relation are sometimes called travel relations. Okay, so that is the something you can just make in your mind. in the further lectures, or I can say in some of the other chapter, I'm just trying to give you the theory of word travel. Okay, for now you just take the this in your mind, that is empathy relation and both of the relation. It's maybe tribal relation. Okay, it's maybe a tribal relation. That's all the theory for about this. Okay, okay. So what is an identity relation? Okay, okay, okay. So sir, identity relation actually somewhat is what? Actually the relation that is your domain part, or I can say the range part. Both are same here. That is a simple for your identity. It means you can just take A related with A. It means your relation is exactly same with your original element here, with your original element here. So if I take if I take A cross A, okay, I'm just giving you the previous point. Okay, if I take this relation only, if I take this I just take this relation. Okay, if I take this relation only, so what is here? The identical relation. So you can say, sir, for identical relation na, I can just take 1, 1 here, for 2, 2 here, then I can just say, sir, 3, 3 here, the 4, 4 here. So for identity relation here, identity, okay, let's assume here only. Okay, so for identity relation, for that example only, that is 1, 1, 2, 1, 2, 2, 3, 3 and 4, 4 here. And if I take, let A is my set here, that is 1, 2, 3, then what is exactly identity relation? You can say, sir, 1, 1, 2, 2 and 3, 3 are the pairs for my identity relation. Both the elements should be same. Both the elements of the coordinate should be same for my identity relation. So that's how the identity relation works for this relation only. Okay, sir. Okay. This is very conceptual and I can say very good question. Let's see this question only. Okay, let's say A be the set of all students, okay, of a boys school. Okay, this question all about your training of your mind. Okay, what is training of your mind? Okay, let's just tight your screw in your mind. Okay, if I take A be a set of all students of a boys school, show that the relation R in A actually is given is what? There have the relation R that is given A comma B. Take the A comma B and this is A is a sister of B. No problem. Okay, there are some students. Okay, there are some students and I'm just taking all those students. That is something the A student that is a sister of our sister of B. Okay, no problem. Okay, I'm just showing this relation actually is empty relation. Okay, sir, I'm just show with my logic only here. With my logic only, there are no what something not in the mathematical thing. Okay, let's say and I can say the R dash. Then I can say the R dash, and for R dash the theory is what? The related is what? The difference between the in the students, the difference between the in the students' heights. This difference between the students' height, or can say students of A and B, is less than 3 meter. Okay, for your sake actually, I'm just giving you what for the 3 meters. For the 3 meters, there are something 9.7 foot. Okay, 9.7 feet. I can say 9.7 feet. Okay, so is the universal relation. This is what? This is comes under your universal relation. How? I'm just using the logic here only, and that is my answer. Okay. So what is the answer here? So sir, if this condition, you can say, sir, take a logic. Just read one line only for the first line. Let A be the set of all students of a boys' school. Okay, sir. It means there are no girls in the school. So how the sister obtained with this relation only? Okay, sir, is there no sister here? Is there no girl in that school? So then it must be no sister here. So I can say for R relation, for R, I just give the statement to you. For R relation, you can say no girls are in the school. No girls are in the school. So ultimately, So this so obvious the relation R is a empty relation. Relation R is a empty relation. That's what simply think. Okay sir, no problem sir. Okay, so this is what, this is my empty R, that is what, that is comes with my logic only. Okay, let's say that for the R dash, let's say for the R dash only. Okay, so what is the R dash thing here? So you can say sir, the R dash is what, somewhere the difference between of A and B is less than 3 meter. Less than 3 meter is somewhat around maybe the 9.7 or the some maybe I take the 9 feet here. Okay, 3 meters. Okay, so you can see sir, so 9.7 feet. Okay sir. So is there any possibility the heights of two students, actually the difference of the heights of the two students is actually more than 3 meters? Is there any possibility? Is there any students which are actually the height of the two students are less than 9.7 feet? In the real world, there have nobody there. That is the height of the difference. Actually, the heights of the difference actually is what, the 9.7 difference. Okay, so in the school and in the class only there are there's some difference of the height, but that should be, or I can say that must be not greater than 3, but this is here is at 9.7 feet. So is this condition are always true? You can say yes sir, because A and B are always, or I can say the difference of the height of the two students always less than 3 meter here. So always less than, so the whole students pairs actually R is my universal relation. Is this the, so for R dash, I can say the for R dash, this is very obvious. Obvious what? There have no pair of students that there have no pair of, or you can say okay, not take the reverse thing. You can just say this is obvious. There have all pair of students. There have all pair of students must have difference in height less than what? Less than 3 meter here. Okay sir, it means all the students must be, the difference of the heights are there must be 3 meter only. Okay, so here all the students pairs I can take for the R dash relation. I can say all the students pair. So for all the students pair, you can say the universal relation here only. Okay, you can say the universal relation here only. Okay, let's start the some exercise part. I'm just taking the exercise first here. That is what, that is just find the first question here. That is what, something, the domain you just find with this, for this relation, and the range. Okay, that is very simple sir. For the domain, you just take the first element. I can say the domain of R, you just take all the first element from the coordinates here. So I can say this is -1, 1, -2 and 2. Okay, so you can say sir you have not formed the relation, or I can say the relation R. So I can say the question actually already give you the relation here only. Okay, so this is what, this is the actually giving you the relation, and that relation only you just find the domain and range part. Okay, if I want to find the range here, then you can say the all the second elements are must be in my range set here. So I can say 1, 1 and 4 and 4 only. Okay, so this is what 1, 1, 1, 4. Okay, with the set theory, I can just say I'm not wanting, or is there not must thing, that is you just must giving the set twice or thrice time. You just take, if you have the element that is in a repetitive manner, you just take only at a one time here. Okay, so I can just take only what, that is 1, 4 only. Okay, this is the ultimate things. You have not taken 1 2 times, 4 2 times. That is not your range here only. Okay, the common numbers must be taken as the one time only. Okay sir. Okay, just quickly and give this So I can say the 2, and r actually is my a comma a cube. Okay, so this is what my relation. Okay, and a is my prime number, less than 5. So you can say, sir, a must be what for the prime number less than 5. You can say, sir, 2, 3, these are the two numbers, or I can say that these are the two prime numbers that is less than 5. So you can just take only the two numbers a here. So for this condition only, I can say the relation here is what, a comma a cube. So a comma a cube actually is my b. So I can just take a here is what, the 2. Okay, because the a is my prime number, and for a equals to 2 here, for a equal to 2, b equal to a cube, and b equal to a cube is what, 2 cube. Ultimately it is 8 here only. Okay, no problem, sir. And let's check what, this is what, the 3. So I can just take a equals to 2, then a cube is what, I'm just writing the thing is here, that is a cube is what, a cube is my 3 cube. 3 cube is what, 27 here, sir. No problem. So the 3 is ultimately related with 27 here. Okay, so this is what my relation. And what saying to you for the question here, you can say the range of the r. So what is the range of the r? You can say, sir, the 8 and 27. So the range here actually is what, the range is my 8 and 8 and my 27. Okay, sir. Okay, so this is the homework to you guys. Okay, so you can just try by your own. You can just take a as a prime number less than 10. Okay, just take the less than 10 here, and just take the pairs here, and try to find whole relation, then the domain of that r, then and the range of r only. So this is what somewhere very similar to our second question, but take also the more number here, that is less than 10, which is prime also. Okay, sir. Okay, let's say the some other condition, that is the fourth question here. What is the fourth question says? The r the relation, that is x comma y, and the condition must be given here is what, x plus 2y equal to 8. Okay, be the relation of n. What is exactly n? I can say the n is here is actually referred to my natural number only. Okay, so all the natural number set I have given to you. Okay, so I can just say my a here, I can just say, if this statement actually means, I can just say that my a here is what, a here is actually 1, 2, 3 and up to there. That is what all about the natural numbers. Okay, so I can just find these relation, this set for the relation. Okay, so I am just taking x comma y from this relation only and try to find this condition. Okay, so for x plus 2y, I am just taking the conditions. Okay, if I take x equal to 1, then just try to solve. If I take x equals to 1, then I am just taking 1 plus 2y equal to 8, and ultimately 2y equal to 7, ultimately y equals to 7 by 2. Is the y is a natural number? I can say this is not a natural number. So for this condition, I am not taking the x equal to 1 here, because ultimately y is also are in my natural number, na? Because y is also belongs to my a set only. Okay, if I take x equals to 2 here, then I must be taken 2 plus 2y equals to 8, and it is simply, I am just taking into here as a minus. You can say this is the 6 and y equals to 3 here only. So is this pair allowed? I can say for the relation r, for this relation only, I can just approve the pair what that is 2, 3 only. No problem, sir. Okay, let's just take the another example, that is what x equals to 3 here. Is the x is equals to 3 here are also defined with this condition? You can say no, sir, because if I take 3 plus 2y here, then I just take 2y equals to 5, and ultimately y is not belong to my natural number. That is what somewhere what 5 by 2 na, that is somewhere what 5 by 2. Okay, sir, that is also not belonging to my set here. Okay, if I take x equals to 4, very simple, sir, that is what somewhere 4 equals to 3y, 4 equals to 2y equals to 8, that is 2y equals to 4, and that is somewhere that is 2. Okay, sir, if I take x equals to 4, then it must be y equals to 2 here. So the second pair in the relation is what, 4, 2 here. Okay, sir, that is also not. I can take 6, no. I can take I can take 5 here, no. I can take 6 here. That is very true, sir. If I can take 6 here, so the ultimately thing is what? The 8 here, 2y equals to 2 and y equal to 1. So ultimately the pair should maybe come in what? In our 6 comma 1 here only. Okay sir, that is no problem. Can I take x7? No sir. Can I take x8? Okay, so let's assume for the 8. Okay, just see the upper part. Okay, upper of the screen. Okay, let's say x equal to 8 here. So what is the x equals to 8 here? I can say 8 plus 2y equal to 8 here only, then 2y equal to 0 only, and y ultimately comes to 0. Is this y actually belongs to my A set here? I am saying no sir, because the 0 not in the natural number, no? The 0 is should be in my whole number actually. So if I take the 0 and then no. Okay, can I take x equals to 9? Then that ultimately leads to negative y's. So are b negative y is acceptable? I can say no. So there are only the 3 pairs here that comes under in this relation only. Okay sir. So my three pair relation is 2 comma 3, 4 comma 2 and 6 comma 1. Okay, so what is the range here actually? So you can say the range for this question only is what? Only is 3 to 1 here. Okay sir. Okay students. Okay. So this is what? This is the somewhere the question. I can just give you the whole scenario. Okay. This 5 question actually similar to the 4 question. I can just give you the homework for you students. Okay. I can just solving this 6 question only here. Okay. Let's say the relation that is comes to with the a comma b, and the condition are there is what? B equal to modulus a minus 1. Okay. So the relation actually comes what? A comma b, and the b here is somewhat b equals to a minus 1 modulus. No problem sir. And I'm just take a comma, and a should be my integers here. Okay, a should be my integer here, and one more condition are there for this relation actually. For what? A should be or can say mod a should be less than 3. Okay, so these are 3 condition I can say which are for my relation only. Okay sir, let's take these condition and take the relation only here. Okay, let's see if I take the relation in here, and I'm just taking all the integers. Okay, so it means there are negative integers also, there are positive integers, so I can just take all the elements with my only what? With my integers part also. Okay, with my integer part also. That is the whole scenario. Okay. Can I take a equal to with the integers now? With the integers, I can just say the whole part. Okay. Can I take a equal to 0 here? So for a equal to 0, b equal to what? A minus 1 what? It is ultimately what? 0 minus 1 mod, and minus 1 mod is what? 1 here. Okay. So b equals to 1 here and a equals to 0. This a actually also satisfy this condition. You can say yes sir, because 0 mod ultimately gives 0 and 0 is less than 3. You can just say yes. So for this relation only, I'm just taking the relation here, and I'm saying for this relation only, you can say the 0 comma 1 are my first relation pair. Okay. Can I take a equals to 1 here? You can say sir, b equals to 1 minus 1. Ultimately it is comes to with 0, and as a is exactly represent with this condition also. I can say yes sir, because 1 is also should be also less than 3. So ultimately actually you can say this pair also acceptable, that is 1 comma 0 here. No problem sir. Okay. Can I take a equal to 2? So for the a equal to 2, you can say the b equal to 2 minus 1. Ultimately it is 1. And for the 2 also, the mod of the 2 is less than 3. That is very true. So you can say this also acceptable here. Okay. Can I take a equal to 3? That is also acceptable, because b, okay, let's see. That is 3 minus 1, and this is 2. B is here, it is 2. Can I take a equal to 3? You can say sir, mod 3 actually less than 3. No sir, because 3 is equal to 3, not less than 3. If the equal to sign there, then it must be true here. So can I take a equal to 3? I can say no sir. Can I take a equal to 4? I can say no sir. Can I take a equal to 5? Okay, the upcoming numbers are not be there. Okay. Can I take negative numbers? Also na, because all the integers you say, the z actually represents what? The integer part here. Okay, this symbols must be known with these symbols. Okay. Can I take a minus 1? Very simple, sir. B equals to what? B equals to somewhere a minus 1, that is somewhere minus 2 mod, and that is B 2. And if I take this condition for satisfying thing, then I take minus 1 less than 3, and ultimately minus 1 mod is 1, and so this condition actually fulfill my whole conditions. Okay, so I can take pair what minus 1 comma 2. That is very true, sir. Okay, comma, can I take a equal to minus 2? Let's see. I can say b equal to minus 2 minus 1, that is ultimately minus 3 mod, and that is ultimately 3. Okay, is this minus 2 less than 3? You can say minus 2 mod less than 3, and this condition also fulfilled because minus 2 mod is 2 here only. So I can say this pair is also minus 2 comma 3. Okay, can I take a equal to minus 3? Okay, sir, let's not check for b, you can just check for this only. Okay, sir, so this is actually not containing, because this ultimately comes with the 3, and the 3 is not less than 3. 3 must be equal to with the 3, na? So I can say I can take a equals to minus 3. No. If I can take to minus 4, no, these are all the numbers that I am not taking for this relation only. So the answer part here is exactly this, the relation. Okay, students, I think you understand this example very easily, and I'm just trying to find the domain and the range of this R actually. So I can say I'm just change the pen here. That is domain R here is what? Domain R here is what? 0, 0, somewhere 1, and somewhere 2 here. Okay, and if I can say range here, that is from R, that is somewhat, okay, no, just there have some other domains also, na, because in my below here, that is minus 1 or minus 2 also. Okay, sir, okay, students. Okay, if I take the range here, then what the range? Okay, can I take 1? Okay, can I take 0? Can I take 1? Then can I take 0? Okay, can I take again 1? I can say no, sir, because the 1 are already written there. Okay, so there have no 1, the other one also. Okay, so I can take 2 here, I can take the 3 here. So this is what? This is my domain as well as my range here. Okay, sir. Okay, let's see the another question here. What is the 7th question? That is the 7th question. That is the relation is what? The relation is actually belongs to a comma 1 by a, and a is actually my natural number. Okay, a is my natural number. Ultimately a is what? A is something that is between 1 and 5. Okay, so what exactly A is? 2, 3, 4, because 1 and 5 are not included there. There have no equal sign here. Then I can say the A is 2, 3, 4 here. So what is my relation? So you can say, sir, the relation thing, or you can say the relation pair expression given in this question is a comma 1 by a. Then I can just say the 2 comma 1 by 2, sir. Okay, if I take the a 3, then 3 comma 1 by 3 here, sir. If I take a4, then 4 comma 1 by 4 here. Can I find the domain and range? Very easy, sir. The domain actually is what? 2, 3, 4. Can I find the range here, sir? Very easy, sir. 1 by 2, 1 by 3, 1 by 4 here only, sir. No problem. Okay, so this is the homework to you guys. Okay, this is somewhat similar to my earlier example that I have given to you. So that is somewhere you just keep in your mind that all the conditions should be fulfilled for my relation only. Okay, so you just take homework. Okay, so thank you, students, for being with my lecture. That's all about our first lecture in our class 12th first chapter, that is our relation and function. And I'm just assuring you, students, that is these lectures or these whole series actually comes in the fun way or more understandable way to you. So this is all about from my side. I'm just taking bye from my side also. So bye bye, tata, see ya. Let's come on the next lecture, and we'll be see you in the next lecture very soon. Bye bye.